and you send a message to someone to leak your IP to that person, right? And this adds some complexities, but it's more privacy preserving because you don't leak the IP to your counterparty, if we can say that. So as I said before, it's based on GossipSap. We add some stuff on top of GossipSap, which is a protocol built by Live Peer-to-Peer, and it's used in mainnet by many blockchains. I think Ethereum for sure, the consensus layer, is using GossipSap. I think you also have GossipSap in Polkadot, and there are many other blockchains and decentralized things that use GossipSap. So there are two types of topics. I think this is important to understand for the demo that I will do later. We have GossipSap topics, right, that are connected to the GossipSap protocol. And then we have content topics. The content topics are an abstraction that we have on top of the GossipSap topics so that the user, it's more user-friendly. So long story short, we will remove in the future GossipSap topics, and then the user will only see the content topics. And the node will handle under the hood all the subscription and unsubscriptions from the GossipSap topics. I think also Vaslav said this before, but we have different RFCs, request for comments. So there are the specifications that we have for each protocol, and you can check them online in this website. I think I haven't touched anything. Right, sleeping. Should be back. Nice. I was worried for a minute. Cool. One more thing on GossipSap. GossipSap, at the end of the day, the only duty or job that it has is to propagate one message from a node, could be node A, for example, to the rest of the nodes, right? And we can do this in multiple ways. The naive approach would be flooding, right? Which means that this node A will send the messages to all the nodes that is connected to. For example, to I, D, G, and so on. And then I will do the same. Will publish or flood with this message to all the nodes in the network. So if you do this few iterations, right, the message that A wanted to send will end up arriving to all the nodes. The problem that we have here is that it's very bandwidth inefficient. You will end up having a lot of duplicates in the network. So of course, if you are node C, maybe you will get the same message from 3 peers, right? This, maybe 3 is an okay-ish number, but this in a real network where you are connected to 100 nodes, 200 nodes, it's too much, right? So GossipSap, it's the protocol that fixes this. You also have other implementations of PubSub architectures like RandomSap that also does some trick in order to ensure that the message is delivered to all the network, but without having a lot of duplicates. There is a very important parameter that is called the replication factor. The lower, the better. So yes, I think there was a question before about the store protocol, or I think someone was asking if we used Swarm or this kind of decentralized storage systems. So we are not using any of these storage platforms or protocols like IPFS, Swarm, and these kind of protocols. We have our own protocol. The thing is that we specify how the interface works, right? So nothing is stopping you from implementing the store protocol in IPFS, for example. As long as you respect the interface that we have, you will be fine. So the backend could be whatever. Right now we have Postgres. We recently migrated to Postgres. And I think one of the most important things to highlight about the store protocol, well, of course, the reason why we have store is because if your node is offline for one day, maybe it's your laptop and you're offline during 12 hours because you went to sleep, then you need, when you are online again, then you need to fetch the data that was sent to the topic that you are subscribed, right? So this store protocol allows you to retrieve this data while you were offline. It's very important to also say that currently we don't have consensus on the data. So theoretically, two different store nodes could store different messages. This is not great, and we are working towards that, so that nodes could continually check the diff they have against other nodes and be in sync. But we don't have any consensus, and we don't have synchronization right now, but it's coming. And yeah, one last comment of the store protocol. There is some trust involved, because the store node that you are using, you have to trust in it. Because right now, we don't have any means of knowing that if you fetch messages from this store, maybe this node is not sending you all the messages, which sucks, of course, but we are working to improve this. Also, we have light protocols. The light protocols, we don't really like this terminology, but it's very similar to what light nodes do in other blockchains. So for resource-restricted devices, maybe you can't, or for sure you can't run a relay because it will consume a lot of bandwidth. You can't run relay in this phone because my data plan will be gone in a few hours, right? So for mobile phones, we have these light protocols that you can kind of trust in a node, and you can publish and subscribe through this node. Of course, there is some trust involved, but yeah, you can always use several ones if you don't want to only rely on one. So yeah, they don't participate in Gossip's app. They are very bandwidth efficient because you don't have to run relay, right? So you will consume not much bandwidth, and yeah, there are some trust assumptions. So peer discovery. I would like to go a bit deeper in peer discovery, not much, but so yeah, in a peer-to-peer network, you have a bunch of nodes that are, who knows, in different countries, cities, data centers. Maybe one of them is at home, another one is in a data center or whatever. So all these nodes, they have to know each other in some way, right? So the peer discovery protocols will allow these nodes to know each other, or to know where to find other nodes, right? Once you know where to find other nodes, then you can connect to them. So for this, we have a protocol, discovery protocol. It's called this disk v5. It's the same protocol that Ethereum is using in the consensus layer. So it's battle tested. It can scale. In the Ethereum network, you have around 15,000 nodes, maybe 20,000 right now. So it has proven that it can scale at least up to this limit. We have other discovery protocols, but I won't go into them. Okay, so if you remember, I have said before that a node can have different capabilities, right? Because we have different protocols that you can maybe implement or not, right? So in order to, for a node to know the protocols that other node supports, right? We use something in the ENR. The ENR is the Ethereum name record. So it's like it's a record that stores your IP, your port, your peer ID, and these kind of things. Long story short, it's a record that tells other peers how to find you. So in this ENR record, we have different bits. Maybe it's too small, but if you have bits or like flags, right? We have relay, we have store, we have filter, and we have light push. These four are not implemented right now. So what does it mean? If you are running relay, then you will have true or one in this field, right? And you will advertise to other nodes that you support this protocol. So if, for example, you want to retrieve messages from a store node, then you will start discovering peers in the network, and you will look for this field, the store one, which is the one that tells you that the node runs store. We are also considering other discovery protocols like Kadimlia DHT. Not sure if any of you knows this one. Kadimlia DHT, it's also from the Leap peer-to-peer stack, let's say, and it's being used by IPFS and other protocols. RLN. Okay, so far we have explained about Waku, everything is great, right? But who is stopping you from publishing many messages in the network, right? I mean, there is no identity in the messages that you send, right? So we need a way to prevent spam and also protect from civils, right? So because of how GossipSap works, it's quite tricky to detect spam, right? Because the nodes don't have a sender, right? They are published into a topic, but you don't know who is sending this message. So you can't really rate limit because you don't have an identity to rate limit anyone, right? And so RLN stands for rate limiting nullifiers. We have some people in the crowd that have a lot of knowledge in this. So if you have questions after this regarding RLN, they will be able to answer. So this protocol provides some kind of pseudo identity that we can use to rate limit you. So while preserving all the properties that we want in Waku, like anonymity and censorship resistant, we can have a way of saying, okay, we will set the limit of messages you can send, let's say 1 message per second, 10 messages per second, whatever, and then enforce this limit. So for us, RLN is very important because it allows us to detect if someone is spamming the network, and it also allows us to penalize this entity that is spamming. I don't want to go into details about this, but the way that you can register into RLN is with staking, just like Ethereum does. So once you stake, you are eligible to send messages at a given rate. And then if we detect, or if the network detects that you are spamming, then we can penalize you by slashing you, just like Ethereum is doing. Important to note that right now we have the slashing part out of scope, at least by now. So the Waku network. We aim the Waku network to be a decentralized network with a bunch of node types. They could be running in the desktop, cloud, phones, by node operators, people also running in dApp node, if you know this hardware. Also, Waku has a bunch of implementations, so we expect that the network has a variety of nodes in JavaScript, in Go, in NIM, and also, different protocols are supported in the network. If you are running in a data center, maybe you will support all the protocols, and you will be subscribed to all the shards. I will explain what a shard is later. And what is the most important, all these nodes are run by people belonging to different entities. They could be companies, they could be individuals, they will be in different jurisdictions and with different interests. This is very important because the risk of collusion would be way less, right? If you have all this variety. Cool. So let's see. Just to elaborate a bit more on this slide that also BuzzLab said, each circle is a node, and you have different topics. This is one topic, this is one topic, and that's one topic, right? So the nodes organize themselves around this topic. So if this node publishes a message to topic B, then it will reach all the nodes that are subscribed to that topic. So the future. This is our 6 months, maybe a bit more, 6 to 8 months time plan. As I said before, we plan to launch the so-called Waku network. We already have a Waku network, just wanted to be clear on that, but we aim for more, to have better properties. So this is what we are working roughly. We are getting RLN ready for production, because right now RLN is not ready yet for production. We are also hardening denial of service attack vectors that you can have in a peer-to-peer network. We are also sharding the network. If you know about Ethereum or many other blockchains or even databases, right? This is nothing new. Sharding the network means splitting the whole network into smaller sub-networks, right? So that it allows you to scale. This is very important because Waku will never scale with a single shard because the traffic would be too high and no single person or entity would be able to run a node because the traffic would be too much. So we are working in sharding a lot. We are working also on off-chain incentives to further decentralize the network. Right now, the crypto incentives, we are a bit far from that. Having economical crypto incentives, just like other protocols, it's something that will take a bit more time and research especially. We also want to decentralize the store protocol because, as I said before, right now you have to kind of trust the store node that you are using. So we aim to further decentralize this and also improving light protocols. So if you are running with your phone, right, you can use the Waku network with some degree of decentralization and guarantees. If you are interested into this effort of the Waku network, feel free to browse this super long link. But yeah, you can see that it's Waku.org on GitHub. And if you want to contribute, we would be pleased to hear your input. So I'm almost done with the theoretical and maybe boring part. So I want to differentiate the different roles that we have in Waku. We have the operators, the developers, and the apps, right? So the operators are the ones that contribute to the network, making it decentralized, right? By running the Waku software. When I say operator, I'm not referring to professional operators. We aim that you are able to run Waku from your house, in your laptop, in a small Raspberry Pi, or these kind of machines. So don't think about professional operators here. Anyone could be an operator. Then we also have developers that develop apps or dApps with D on top of the Waku network. And then we have apps being developed by developers, right, that are using the network. It's important to note that these apps can be also operators, right? Because if you run, for example, right now we have the status desktop app. If you have it in your laptop, then you are also being an operator. You are going to contribute to the network with some limited resources, but yeah, apps are connected to operators. So, after this boring talk, I can take maybe a couple of questions very quickly, and I would like to go into the workshop. It's going to be quite short, maybe 10, 15 minutes. So, any question before going into the workshop? Any clarification? Cool, so then I guess I was super clear with my explanations.
So, great talk again. Thanks. I am wondering, regarding the censorship properties, like if I would imagine being like China who wants to monitor some topic, like the PubSub architecture is actually very nice for them, isn't it? Like that they can monitor the topics and then they can see it, and then like possibly with their like big firewall they could, for example,
yeah, but what can they see?
I mean the payload, no?
Yeah, but the payload could be an encrypted payload. So they will see a bunch of bytes that doesn't make any sense, right?
Yeah, but I mean also they could filter it based on the topic. And that the topic is not sort of like encrypted, right? So
the topic name is not encrypted. But, I mean, the topic could be 14738, right? What does it mean?
Yeah, so I guess, well, my question is, well, I guess there is no question. But like, I'm wondering, isn't this actually helping for censor, like this sort of architecture?
I mean, it's a great question, but I don't see how you can censor, right? Because we don't have any on-chain identity, right? So a message is published, and this message doesn't have a sender, right? On Waku level. You can include this sender in the payload, but we don't see it. It could be, I mean, you can define your own types, protobufs, whatever, in the payload and do whatever you want, but no one can see anything. I mean, what is the criteria that you would apply to censor?
So let's say that you have app that, like for example, you have communication app for revolutionarily in China, right? They want to make a coup, and they use this topic, and like they figured it out that they use this topic, and suddenly like wow, they have access to everything.
Yeah, that's a great point. Actually, I think Hanno wanted to answer or say something. Feel free to go ahead.
So what makes it difficult to censor here is the decentralization. Where are you going to filter, right? So if you, firstly, you have to position yourself in the network, and then you could potentially be a node in the network that drops certain traffic, right? So maybe you have some algorithm that you can detect the encrypted traffic, but you can maybe shape it, do some kind of shape detection of traffic, and then determine, oh, this application is an application that I don't like. You're just one node in the network. Everyone else is going to remove you from the network based on the peer-to-peer rules, right? So there's no central point to censor traffic from. So the decentralization of the network is the main censorship resistance that you bring in. Then inside the traffic, there is nothing that links traffic to anything, right? You have the pub subtopic, which is a shared topic amongst, by approximation, all applications. And then there is a possibility to use content topics within that that doesn't link to a specific application necessarily, but could be used by applications. But there is no way to specifically censor one of those applications without first positioning yourself in the network, and then you will just be removed from the network unless you can do a takeover of the whole network. Now that could happen, right? So you could have a 50+1 takeover of the network, and we should be as resistant as possible to that. The larger the network, the larger the k-anonymity set, the more difficult it becomes. I hope that answers.
Yeah, thank you for your comment on how it's difficult to censor traffic within the network. I wanted to bring up a point about your China censoring stuff case, which is that what they do right now, and I feel like in that case what they can do is just to ban the entire network. Basically, as long as they can get a list of all the IP addresses of all the nodes that participate in the network, and or you know, if the packets that go through this network aren't obfuscated, like Tor's Snowflake protocol, for example, they can easily do that. Yeah, I was just reminded of a talk I heard by the founder of my company the other day that distinguished between like two kinds of censorship resistance. One is like resisting filtering between different kinds of traffic within the network, which is what I feel like everybody was talking about, versus the ability by your ISP or by a state to ban the entire network, which I feel like is much more feasible in this case.
Yeah, it's a good point. I have never thought about these two types of censorship. It's very interesting. I think in the Waku case, to be real, when you participate in such a gossip subnetwork, right, then you are revealing your IP to the network. So you are exposed to these attacks. Of course, there are many ways of hiding this. I won't say any names, but you can hide your IP if you are very concerned about that. So this problem we are not solving on Waku, but it's already solved by off-the-shelf protocols. So, but yeah, it's definitely a concern. Cool. If I may, I will jump into the workshop because I don't want to go over time. If you're interested in running it, you can type this tinyurl.com Waku etc. You have a bunch of commands in there that you can run. And you have also this QR code if you can even scan it, but that should be fine. So before starting the talk, I checked this. download speed for 0.04 megabytes per second. But as a good engineer, I always have a backup plan. So I have a video that I can show you with the workshop, a small workshop or demo, if you can call that. So let me switch. So if you browse that link that I sent to you, you have a bunch of commands in here. So I guess you can see it, right? Yeah. You will need Docker to have installed Docker, and I will explain briefly the different arguments that you need. So first of all, you need the Docker image, right? We have the version release 018. Then in this case, you can run a relay protocol only, so that's why it's true. Then we also discovered you also enable disk V5. If you remember before, I was saying that disk V5 is the protocol that is used for discovering other peers. Yes, you enable the RPC endpoint so that you can interact with your nodes, and you also have the topics that you are subscribed to. We have a bunch of topics that you can subscribe to. I would recommend this one because we have less traffic in this one. So, right, I mean, I don't think you can run a node from here, but with this, your chances of being able to do it are higher. And yeah, then we use this DNS discovery URL. This is like hard coding a set of bootstrap nodes that you will use when you start your node. So you will fetch some peers from this URL that are encoded there, and then the rest will be totally decentralized with disk V5. But yeah, of course, you always need an entry point into the network, right? You can use our fleets or nodes, or you can use your friends' one if they are already in the Waku network. We have a bunch of public fleets, as I was saying, you can use, and yeah, some of the topics that we have. So I will try to run this command so that you can see that Waku exists and we are not making this out of thin air. So if I paste this, hopefully you can see the logs. So with this, you are now part of the Waku network. Your node will be relaying traffic and different messages in the network. You can see that the node setup is complete now. Then your node will try to discover other peers and connect to them. We should see in a bit the amount of connections that your node has, or maybe not. Yeah, so I will fall back to the video. Cool, so with this, you can see that, maybe you can't, but the node is trying to connect to different nodes. Some of these connections will fail because some nodes are maybe behind a NAT, which means that the ports are closed. So they can connect to you, but you can't connect to them, right? And yeah, I don't think you can see much, so. So in this example that you also can't see, I think, I can try to zoom a bit. Sorry about that. I wasn't expecting this internet. Yeah, so long story short, we have different RPC calls that you can see in the document that I shared with you, where you can, for example, post a message. So if you call this RPC endpoint with a message and a given topic, then you will be able to publish that message to a given topic. So I want to leave some time for questions. So I will only show you one last thing that is quite important. Does anyone know DAppNode? It's a company, a project. DAppNode, hands up, please. Okay, I can see a bunch of hands up. So I won't do a promo of dApp node because they will do it later. There is going to be a giveaway of a dApp node. A dApp node is a machine. It's an Intel NUC, this size maybe, something like this. It has like 32 gigabytes of RAM, a bunch of terabytes of disk space. And long story short, you can run almost every blockchain in this piece of hardware. You can run a Bitcoin node, you can run an Ethereum node, and you can run a Waku node. So yeah, dApp node will do a giveaway later. I think it's going to be by the end of the day. So stay tuned for that. And yeah, also if you get this dApp node, please run a Waku node. So very quickly, I want to show you how easily, because I'm not sure if all of you are tech savvy here, but dApp node, it's a project that allows you to run nodes, in this case Waku, without having any knowledge of coding, programming, or even this kind of thing. So you can connect to your dApp node by creating a tunnel with a VPN. Technicalities that you have a button for that, and this is the dApp node interface. You can see on the left side that you have a dApp store. It's like the App Store in any iPhone or these companies. And if you go to the dApp Store and you search for Waku, you can see Waku there, you can just hit install and you will be running a Waku node. You have to configure it with few parameters. For example, the network that you want to join, a couple of clicks. The topic that you want to subscribe, also one click. The privacy settings that you want to have, like paranoid or customs. Also the agent name, whatever. And then if you want to enable the experimental features. We really appreciate people running with experimental features because this allows us to further test our protocol. So yeah, if you submit, then you will download the package. It's actually downloaded from IPFS, so it's quite decentralized. You are not using Docker Hub. And after a few seconds, your node is installed, as you can see here, and then that's it. In this dApp node, then you are running a Waku node, and you are contributing to the network. So we also have a post, if you're interested, where we give more details about all these things. You can change the configuration on the network, ports, technicalities that, I won't address now. So with this, I would like to conclude my talk. Thank you also, Václav. This clap is for both of us. Thank you so much. So yeah, if you have any questions, we have maybe 15 minutes, I don't know, something like that, I guess. Unless someone stops us, we can just talk a bit about Waku. Come on, guys, don't be shy. We have to make the most out of this. 15 minutes are very valuable.
Yeah, thank you for the talk, Alvaro. So, so you mentioned that Waku relies on lib peer-to-peer and gossip sub, and I guess for scaling Waku, to millions of nodes or at least hundreds of thousands of nodes, you need gossip sub to also scale it to that level. So my question is whether you have done studies to really go to the extremes of scaling for gossip sub.
Yes, we haven't done like proper research on how. I mean, the research question here would be how many gossip subtopics you can have in a network, right? Ethereum has maybe 6, 8 gossip subtopics, which is nothing, and I'm not sure if someone has scaled beyond that, right? So the question we should answer here is how many gossip subtopics we can scale to. We haven't done this research, but we plan to do it. However, for the first Waku network release, we are going to have few shards, right? One shard is one gossip subtopic, and it's going to be in the order of magnitude of 100, less than 100, tens, so it's going to be quite low. It's also important that it's not only about scaling Gossip Sub, it's also about using Gossip Sub resources efficiently, right? Because, and we have had this issue in these last months with some of our clients, let's say, that you can't really use Gossip Sub to send 1 megabyte files, images, or these kind of things, right? Because if you have 1 million people sending 1 megabyte images all the time, it's impossible. This will never scale. So going back to my point, it's not only about scaling Gossip Sub, but using the resources efficiently. And for this, we plan to limit the maximum message size that you can use. Right now is 1 megabyte, which is quite high in my opinion. And we plan to lower this to few kilobytes, maybe 50 max, 100, something like that, or even less than that. We are talking with different users of Waku to ensure that this new limit, it's fine for them, because we are seeking for feedback before taking this decision. You may think that, okay, if the limit message is 5 kilobytes, maybe if I want to send 50 kilobytes, I can send 10 messages, right? It's not as easy as that, because we have RLN to rate limit you. RLN will impose you a limit on the maximum messages per second you can send, right? So we have this triangle of, not triangle, but yeah, the bandwidth consumption, then the bandwidth consumption, then the maximum message size, and the maximum messages per second. It's like a trilemma we have. I think I got over time, but if we have more questions, feel to take it.
Thank you.
Yeah, one more question. So regarding to RLN, does that mean that when you want to use Waku, you need to basically have crypto and connect and stake? So it is, because I so far thought about Waku as not blockchain, let's say, connected, but this makes it connected, right?
Yeah, that's a great question, and it's also a concern we have. First of all, you have like an entry barrier for the users, because you have, we will start without staking. So you won't have to deposit any collateral, but you have to sign a transaction. Maybe the gas is quite low, but you have to have some ETH in your wallet to sign this. And your second question was, I think
There wasn't, but since you're talking. So you are running this on mainnet, or plan to run it on some L2 or something?
Yes, so Waku aims to be chain agnostic, so every RLN is compatible with every EVM machine, right? EVM blockchain, right? So right now I think we will go with Ethereum, but it's a decision that we haven't really, I think, maybe someone, Ariman maybe can elaborate on that, because he's the one working with RLN and the testnet.
Yeah, so RLN is chain agnostic. It's not only EVM. We can deploy to any chain. And basically, the Waku public network is the one which in the future will have a requirement of stake. But we've allowed our users or applications to decide on their own what is their registration criteria and their verification criteria. So we leave it completely up to the applications as they want it. But to use the Waku public network in the future, you would have to do this, because that is an opinionated node implementation of the Waku libraries. Does that answer your question?
Hey, yeah, I love the talk. I'm really excited about what you guys are working on, and I guess I'm really curious in terms of the incentives. I don't know, naively, this is the first time I've heard about the project. I love the ethos behind it, but just from a pure incentives perspective, I guess my first question is like, how many altruistic nodes are currently running? Just curious.
We have between 1 and 100, between 100 and 150.
Okay. All right.
Most of them are from the status.
Gotcha. Okay, that makes sense. And then, do you guys have some sort of timeline for some sort of incentive structure? Because I don't know, naively, I would be concerned. Like, I'm curious to use the protocol, but like, I'm a little concerned that without incentives, there's probably not enough third-party actors acting as additional nodes to make it reliable. So I'm just curious what kind of timeline you guys are targeting there. And
yes, that's a very great question. So we have different types of incentives, right? You can have crypto economic incentives on chain. You can also have on-chain economic off-chain economic incentives, and you can also have indirect non-economical incentives, right? Like for example, answering to your question, we don't have crypto economic incentives right now, and it will take some time until we have something similar. It's quite tricky. But we are quite lucky that if you want to run, let's say that are you aware of the status app?
No.
Okay, yeah, no,
I just learned about it today.
Exactly.
But prior to
so I
that,
think
no, yeah.
if you want to participate in the network and you want to get messages, right, then you have to also relay messages because your node has a reputation, a score attached to it. So if you, by using Waku, you also contribute to the network without noticing, right? It's like if you have just BitTorrent, right? There is some score mechanism that if you contribute more to your peers with bandwidth, files, or whatever, then these peers will flag you as a better peer, and then you will get more bandwidth, right? So in the next 6 months to 1 year, we are going to play with this kind of non-economical indirect incentives, right? And I think they should be enough to guarantee some level of decentralization without having the end game that would be the crypto incentives. But it's a great point and concern.
Awesome. I actually prefer non-crypto incentives because I think a lot of the crypto incentives, unfortunately, can be gamed. So yeah, I think the BitTorrent style is much better to explore first. So that's awesome to hear. And then just curious, in terms of like latency, what is an estimated like message delivery time? Just curious.
Yeah. Great question. Also, we get this question a lot of times, and it's tricky because it depends a lot, right? Sure. It depends on the amount of nodes that you are connected to, and this is a flag that you can configure in your node. Okay. It depends also on the amount of nodes in the network, on the amount of topics, on the message size, because if you increase the message size, then the latency is not only the message latency, but you add some latency that you have to download this file, right? So if you send 1 megabyte, same setup with 1 kilobyte and 1 megabyte, the delay will be different because you have this extra delay on top. So sub-second.
Okay, very cool. That's
Worst
cool.
case,
Great.
sub-second, which is quite okay for a chat
Yeah.
application or this kind of thing.
Okay, very cool. Thanks.
Thank you so much, guys. Enjoy the rest of the day.